Aerospace Engineering by Tristan Moore. Have you ever wondered what aerospace engineering is? Aerospace engineering is the science behind flight. Aerospace engineers are responsible for the safety of passengers and the safety of citizens with military vehicles. You might be wondering what classes you should take in high school if you are interested in aerospace engineering. Some classes you should take include Algebra 1, Algebra 2, Geometry, Statistics, Calculus, Biology, Physics, and Chemistry. The classes you will take in college get more difficult. For example, if you go to Georgia Tech for aerospace engineering, you will end up having to take physics, calculus, chemistry, statistics, dynamics, deformable bodies, technical communication, aerodynamics, structural analysis, design system engineering method, system dynamics and design, fluid and solid mechanics, aircraft flight dynamics, jet rocket propulsion, aircraft design, circuits and electronics, and even a few history and English classes. There are a few colleges nearby that offer bachelor's degrees in aerospace engineering. A few of these schools include Georgia Tech in Atlanta, Georgia, Virginia Tech in Blacksburg, Virginia, and NC State in Raleigh, North Carolina. There are a few scholarships available to aerospace engineers. Some of these scholarships include the Aerospace States Association, the American Institute of Aeronautics and Astronautics, and the NASA Aeronautics Scholarship Program. At this point, you might be wondering where you would end up working if you became an aerospace engineer. A few companies include Northrop Grumman, Lockheed Martin, and Boeing. For my interview, I interviewed Beth Iliff, my mother's cousin's roommate at the Air Force Academy. She graduated from the Air Force Academy with a bachelor's degree in general engineering. After she graduated from the Air Force Academy, she went on to serve 6 years of active duty and a total of 28 years including reserves. Her main job was to analyze the F-15s, C-130s, and helicopters to make improvements in speed and efficiency. She also did work on C-130 engines and at one point worked in an Army tank factory in Ohio. Through this interview, I learned that if you attend the Air Force Academy, you will still have to take a few history courses as compared to some of the other colleges at the time. My first sample problem is not a super difficult problem. Let's say you have a C-130 Hercules and you have to fit a truck, 20 soldiers, and a pallet of equipment on this plane. In order for it to fly at its most efficient level, you have to balance the equipment perfectly. So in order to do this, what you have to do is you have to take the total amount of weight on the plane and you have to divide it by 2 so that way you know where to place it on each half of the plane. Secondly, you have to know how long the cargo bay is so that way you know how much room you have to work with. Total, there is approximately 15,000 pounds of cargo. The truck weighs about 8,000 pounds. Each soldier weighs 200 pounds with gear. There are 20 soldiers, which means 4,000 pounds. The pallet with more of their equipment weighs about 3,000 pounds, giving you a total of 15,000 pounds. So, you end up with 7,500 pounds on one side and 7,500 pounds on the other side. To do this, you can put the soldiers at the front, which gives you 4,000 pounds at the front. Then you can put the truck in the middle, but slightly off center, so that way there is 3,500 pounds to the front of the middle, and 4,500 pounds to the back of the middle. On top of that 4,500 pounds in the back, then you would place the gear, which is 3,000 pounds. Giving you 7,500 pounds in the front and 7,500 pounds in the back. My second sample problem is a little bit more difficult. In this problem, you will be calculating the rotor speed in a helicopter or any other propeller-operated vehicle. This calculation is not super difficult. First, you have to find the circumference, and the formula for circumference is 2 pi r. Once you know what your circumference is, then you have to calculate the period of one rotation, which can be done by timing how long 10 rotations take, then dividing that by 10, as compared to just one rotation, unless you have the instruments to perform that calculation. The reason you don't want to just record the time for one rotation is because of human error. Once you have the period, you divide the circumference by the time it takes to complete one rotation. This should give you inches per second. To get miles per hour, you just have to use dimensional analysis. Alrighty, so let's say that you're calculating the rotor speed of a C-130 Hercules engine. In order to do this, you will need two different pieces of information. First, you will need the circumference of the path traveled by the tip of the rotor. Then you will need the revolutions per minute, or RPMs, of the engine. For the first piece of information, all you really need is the diameter of the path traveled, which is 13.5 feet. In order to find the circumference, you have to multiply the diameter by pi, which gives you 42.4115 feet. So now for the second piece of information. Let's say that the engine is operating at 1000 RPMs. We use RPMs instead of the period because it is too difficult to calculate the period based off of human eye coordination and getting the actual proper timing. So let's say that the engine is operating at 1000 RPMs. It's easy to convert RPMs to revolutions per hour because minutes convert very easily to hours. So you take 1000, which is the revolutions in 1 minute, and you multiply it by 60, which is how many minutes are in 1 hour, and you get 60,000 revolutions an hour. So now that you have both of your pieces of information, all you really have to do is multiply the two together. Once you multiply the two together, you get 2,544,690 feet per hour. But who really measures speed in feet per hour, especially whenever you're talking about something that's going that fast? So we're going to convert that down to miles an hour. So in order to get that down to miles an hour, you have to use dimensional analysis. So basically you take the 2,544,690 feet and you divide it by 5,280 feet, which is how many feet are in a mile. This results in 481.944 miles per hour, which is your final answer. Well, this is the end of the video, so thank you for your time, and I hope you have a wonderful day.